recording. Okay, so 3-4 again, it is going to combine everything that we've been doing throughout the chapter. Okay. Just trying to write it with a different way. Evidently, that's not going to work for us. Yes, not for me. Okay, so just to review with two properties, you already had these in your notes. You do not need to write them down again, but should you know them? Yes. You should know the one-to-one property. When the bases are the same, what are the same? Exponents are the same. In logarithmic form, when the bases are the same, the ofs are the same. Inverse property, I have log a to the log base a of x. It equals x because what? The bases are the same. Yep, I got an eraser. The bases are the same. So those are the same, so it's x. It's what the of is. And then when we have it in logarithmic form, log base a of a to the x is just x. That's property 3, right? Okay, that we used a lot. Okay, questions about either of those two properties? Misconceptions? Okay, we have used them over and over and over again, have we not? Yes?
Ma'am.
And you are going to. The whole goal is to use the properties that you have to be able to solve. Am I good?
Yes, ma'am.
Okay, so we have the equation 2 to the x equals 32. So the first thing I need to do is rewrite it. Rewrite it how? Nope, not on this one. We don't have to. We could, but we don't have to.
Write it.
Same base.
Yeah.
Okay, so 2 to the x equals 2 to the what? Fifth. So the solution is x equals 5, and that was the 1 to 1, wasn't it?
Yeah.
Okay, now I have the natural log of x minus the natural log of 3.
Would that be x over 3?
It would be the natural log of x over 3. You're correct. And I'm going to make it equal. Can we do it y? Because it has to equal something, yes? Yeah. If I'm solving it. Do you maybe want to rewrite it again? Exponential? Okay. So, what's my base? E to the y equals x over 3, right?
Yeah.
So what does x equal? 3. I agree with 3.
Over 1.
Wouldn't I just multiply both sides by 3?
Yeah.
Yeah?
Oh, yeah.
Yeah. Just because we have those two variables, don't lose track of what the algebra you know. Okay? So I have x equals 3e to the y.
Now would be
We didn't use the one-to-one, we used the what? Inverse. Now sometimes we use the inverse and the one-to-one, we use them both. Yes? This one we did not. Okay, 1/3 to the x equals 9. I wonder if that was supposed to be equal on the last one.
find the same base.
Find the same base.
1/3 to the negative 3. Right?
Um,
No. 1/3 to the negative 2.
1/3 to the x equals 1/3 to the negative 2. Now that's how Ethan's brain works. My brain does not work that way. Anybody else?
I honestly don't know what we're doing.
We're doing what we've been doing for a week, over a week. We're getting the same
Mine
base.
would have been 3 to the negative x
3 to the negative x. Go ahead.
3 cubed. Or 3 squared.
3 squared. Okay. Either way, we're going to get x equals
Negative 2.
-2. Yes?
Yeah.
And that is the...
1, 1.
Okay, actually, this was over 2 weeks ago. But we've been using every day. When I can get the same bases, are the exponents equal? Yes. Okay. If I went back to b and made that an equal and not a negative, what would my answer be?
Instead of the negative on B, it can equal something.
So what would the answer to this be?
Just 3.
Just x equals 3, wouldn't it? Because we have the same bases, and that would be the 1 to 1.
Yeah.
Okay, I'm wondering if that should be what it was.
Wait, so the inverse wasn't right?
No, what we did was fine. I'm saying when I typed it out, I think we did the problem that was in front of us. Yes.
And we did it right.
Yes.
What property was it?
When this was an equal? When this was an equal?
Well, you just
Wait. So
When that was an equal, I'm asking you, is that your question?
no. It was the last one.
It was 1 to 1.
This one right here was 1 to 1.
Didn't you buy the whole thing?
Yeah, I did, but when I switched computers, I can't. Evidently, it didn't get deactivated.
So you pick.
No, I just have to contact them. Okay, e to the x equals 7. So, always try to use the 1 to 1. Can I use the 1 to 1?
No.
No. Why not?
Because 7 is not, they're not.
Yeah, I don't want to work out what power of E7 is. Do you? Okay. So then we should change bases or change it forms. Yes.
Log.
It's a natural log.
Natural log.
Yeah, natural log of x. Wait, no, 7.
No, just a second. So natural log of 7
Yeah.
equals what?
Equals x.
X. So the solution is just what? X equals the natural log of 7. And what property was that? Inverse. The inverse just uses the fact that I can change it. I can change it to the other form. And it usually is, well, I'm here, what do I do now? When you say, what do I do now, guess what you're probably going to do? Switch it to the other form. Okay, the next one, I have the natural log of x equals -3. Can I use the 1 to 1?
No.
No. So switch forms. So I'm in
E to
exponential.
the negative
I mean-
3 equals x.
E to the -3 equals x. Now I cannot leave my answer that way because I cannot have negative exponents, correct? It 1 over e to the third or cubed equals x. And what property did we use again? Inverse. Now, you don't need to identify these, but when I ask you what property you use, should you know and be able to tell me? Yes. Okay, try F on your own. And you can go on to G. I think F and G are pretty much the same, aren't they? Bradley, what's your answer for F? Do you have 10 to the negative 1 equals x?
I thought you can't have a negative exponent.
I can't. That's why I asked what
That's
the
not
answer was.
solution column.
Okay, how did I know my base was 10?
Because
There is no base. So Garrett, what do I have to do to that 10 to the negative first?
Would it be 1/10?
So x equals 1/10. And what property did I use again?
Inverse.
Is that what those location buttons?
Yeah.
Okay.
Evan, do you get 3 to the 4th equals x?
Yeah.
Ethan, what's your answer? Because I expect an answer on this one.
X equals 81.
X equals 81.
Yeah, I was doing math when you called on me, so you
Oh,
messed
okay.
up my math.
And what property again?
Inverse.
Inverse. I do expect you to work out your 2's to about 6. That's 64. It's not too hard to do. Okay.
That's 3.
Not 2.
What?
That was 3 that we did.
Yeah, but 3 to the 4th is 3 times 3 is what?
9.
And 9 times 9 is
81.
81.
See, I went to 27,
Okay, that's.
and that's where I got.
Okay, so I expect you to do the ones. Anything 1 through 25 squared, I expect anything 1 to 10 cubed, and then 3's and 5's, I expect further. Questions, guys? Those are the basics. Okay, that's like the first section.
Yeah, I know.
That's.
Okay, so the strategies we used, if you want to write them, you may, but if you don't have to. We rewrote the original equation in form that allows us to use the one-to-one property. The first thing we should always try is what? What property?
1.
One-to-one. Why should we try one-to-one first?
Because it's easier.
It's easiest, correct? Then the next thing we should do is rewrite it. If we're in exponential, we should go to where? Logarithmic. If we're in logarithmic, we should go to
Exponential.
exponential. Okay? That's how we should work these things. Questions? Is that what we did with every problem?
No.
Yes, ma'am.
Yes. Okay. But we have to get it there. It is not always where it's right away there where we can do that. So I have, and sometimes it is. Okay, I have solved the equations. That's interesting.
You're interesting. Yeah, you
Don't
are.
give it
Okay, there it goes. Okay. Your directions, give it a minute. This is not the slide it should be on.
You know what that means? No video.
That's what it's going to mean. I don't know why it's...
Yeah, the only time the video doesn't work is when somebody's gone. So
I know.
It would make sense for it not to work.
Let me pause it to
Did
see.
You don't want to.
he get to
Wait, is this still not the right side?
No,
that one?
we should be on A. Is it switching now? Yes. Okay.
It's switched like 80 times.
Yeah, because I was hitting it a million. Okay, so from here on to the end of the slideshow, the directions are solve the equation. That's it.
How can the exponent have an exponent?
There is no what?
Oh,
Oh, it can. Why not?
I didn't know it could.
Why can't you?
Why can't it?
Because it's not y.
Okay,
It's an exponent?
so e to the negative x squared equals e to the negative x minus 4. What do you want to use?
Factor out the negative.
1 to 1.
One-to-one property. So my one-to-one property says that the bases are equal then.
The x's are equal.
Exponents are equal. So now I have quadratic. Yes?
Yes.
What do I need to do with every quadratic before I do anything with it?
Get it to.
Set it equal to 0.
Set it equal to 0. And I'm going to add over the x squared. Everyone good with that? So x squared minus x minus 4. And then how do I solve it? Factor it. So factor it. You have to use what?
Quadratic.
Quadratic formula. I saw a few scowls. Okay, so quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, factor it great, but it didn't factor, so I have to use the quadratic formula. So we have x equals, well, negative b, so 1 plus or minus the square root of 1 plus 16.
Yes.
I mean, the answer is obviously 2.56, 155, 2813, and negative.
Yeah, no.
155,
No. So 1 plus or minus the square root of 17 over 2. Yes?
Yep, that's exactly what I said.
Okay. Now, is there any limitations on the domain of what I can put into an exponential function?
No.
No? There's no limitations. It's all real numbers, right?
Yeah.
So are both answers good then?
Yes.
Yes. If that was a logarithmic function, we would have to stop and say, wait a second, 1 minus the square root of 17 would be negative, wouldn't it? I didn't ask what, but would it be negative?
Yeah.
Yes, because the square root of 16 is 4. So we know negative, the square root of 17 would be bigger than 1. So if that made the problem, original problem, negative input, then we couldn't do it. So do we have to stop and think about our domains when we do logarithmic problems? Yes. Do we have to with exponential?
No.
Why not?
Because it's not in.
Because the domain is what?
All real.
All real numbers. Okay, B, 3 times 2 to the x equals 42.
You can't distribute in the 3, can you?
You know, can't distribute it in the 3, so what do we have to do with it?
Subtract the 3 over.
Divide it over.
Divide it over because it's multiplication.
Oh, yeah.
So 2 to the x equals, I get 14. What do you guys get?
14.
Okay? Well, the next step would be to get 1-to-1 property, yes?
Yeah. And that
Can
would
I get 2 to be a power of 14?
Nope.
No.
No. So I can't do that, but I needed to still solve for x.
Yeah.
Rewrite it.
Rewrite it.
The long version.
Log base
2.
2 of 14, which is 2 times 7, yes?
Yeah.
Because I'll probably have to do something with that, right?
Well, if you're saying-
Equals x.
Oh, then the A's like
Well, not yet. You gotta do one thing first. What's multiplication?
Addition.
Addition, so we need to expand it. Because Evan saw that the base and the 2 were equal. Yes, Evan, that's what you were.
yeah.
Okay. Now, if there wasn't a 2 in there, I would have just left it log base 2 of 14. Okay. But is there a 2 in 14?
Yes.
Yes. So what is the log base 2 of 2?
1.
1. So x equals,
Log base 2 of 7 plus 1.
I would have written it the other way. I would have written it 1 plus log base 2 of 7. Personally. Does it matter?
No.
Nope. I like it this way because then I know what's in and what's out. I know I have my parentheses there, but I still know what's in and what's out. So, I used the inverse property. I used the multiplication property to expand it, yes. And then I used property number 3 or 1 or 2, right? The power property. But do I have an answer now? Yes. Now, I couldn't put that in my calculator. If I wanted to put that in my calculator, I'd have to use what formula? Change of base, which would be 1 plus log of 7 over log of 2, or 1 plus natural log of 7 over natural log of 2. Okay? So do I need to remember my change of base formula?
Yeah.
Yes. Are you going to get to use all your formulas a lot?
Yeah.
Yes. Okay, so natural log of 5 minus natural log of x equals 0. Natalie, what do you want to do with that?
Solve it.
How? What do you want to try?
I wanna try solving it the way you say.
No, you try something. There's a couple things we could do. Give us something.
Do divide since it's
Hmm?
a fraction.
Okay. Callie says we can make it a fraction.
Yeah.
Yes?
Compress it.
Okay. You want to compress it? Condense it?
Condense, not red.
Okay. So we have the natural log of 5 over x equals 0. Okay. Garrett, did you want to do something else?
Yeah.
What did you
What I
want to
did
do?
Was I added natural log of x to the other side.
Wow.
X equals 5.
And x equals 5.
Job, Evans.
But that's okay. We're going to keep going with this one. Okay, so natural log of 5 over x equals 0.
So
X equals 0.
No,
x equals 5.
no. I need to do what?
How'd you find that? Isaiah?
Hold up.
Because it,
How come X is not
Zero
equal
and-
0 in that situation?
We have to switch forms, yes?
Yeah.
Yes?
so e to the
E to the 0
yeah.
equals x over 5?
We can't
Why would
have
it
a
be
zero
X
x
over five?
exponent, so that would just be 0, wouldn't it?
No.
Nope, it'd be
One.
1.
It'd be 1
Then
Why would it
multiply
be
the
x
5
over
over.
because we... Oh, it's not x over 5, it's what?
5
Over x.
5 over x, sorry. Thank you, Isaiah.
I was like, what?
Okay, so we have 5 over x.
Multiply x to both sides.
So x equals
5.
5. Now, we could do Garrett's method because there was nothing else in my way, correct? There was no, it was 0 on the other side. It wasn't 6 or anything like that. If there was a number on the other side, could we have used his way?
No.
No. If there was a number other than 0 on the right, we would have had to use this way. So it all depends on what is given to you. Just like any other equation, is there infinitely number ways to solve it?
Yes.
Yes. Okay, 1 over 5 to the x equals 125.
Did we do this one?
Did we? Well, you
No,
better get it right then.
It's similar.
It's similar. We've probably done it before.
It's similar to the 1/3 x
Mhm.
equals 9 one we did.
So what property you guys going to use?
1 to 1.
1 to 1, because 125 is 5 to the what?
5th.
5 cubed.
Cubed.
Dang it.
5 to the 5th is very large. That's 125 times 25.
It'd be 5
So 5 to the negative x,
equals 5 cubed.
5 cubed. So x equals
-3.
negative 3. And I know there's some of you in here that would have just said 5 to the negative x.
Yeah. Negative x equals.
Not, no.
No. That's
No.
what you said.
That's what I
5 to
said.
the x.
1/5 x
X
equals
was
5 to the
1/5,
1/5.
To the
1/5
negative.
negative 3. Okay, either way, is it right to do it that way?
Uh-huh.
Yes. Do you need to show me your work?
No.
Yes. Writing the problem down is part of your work as well. Because I'm going to tell you there's a lot of problems. When you get on this page, it's just a lot of problems. Odds are if you go back and forth to your page, you're going to be ended up on 2 separate ones, aren't you? So write your problem, please. Questions before I move on?
No.
Okay. E to the x equals 13 and natural log of x equals negative 10. I think I'm going to try it.
-8.
Negative 8. Try both of them on your own.
we have the same thing right on the paper, so I'm pretty sure you cheated off me, but.
Probably.
Yep.
Telepathically.
Questions? Okay, e to the x plus 5 equals 60. Okay, who wants to take a stab at it? Bradley, go ahead.
I subtracted the 5 over,
Good job. Oops. Didn't have my pen on.
which got me e to the x equals 55.
Uh-huh.
And I put it in natural logs, so it would be natural log of 55 equals x.
And there's no reason, good job, great job. There's no reason to go any further because, again, our base is e, right? And, like, if our base was 5, should we go further?
Yeah.
Yeah, because is there a 5 in 55?
Yeah.
Yeah.
2 of them.
There's 1. Okay,
So I see 2 5s up there.
natural log, not natural log, log base 3 of x minus 5x minus 1 equals log base 3 of x plus 7.
1 to 1.
1 to 1. Right away, 1 to 1, they're all by themselves. So then what?
So
5x minus 1 equals x plus 7.
And then we have a basic algebra problem.
yes.
So x equals
2.
2. So sometimes you're going to have an answer, and sometimes you're going to have an answer that needs to be put in a calculator if you want approximation.
Yeah. The 1-to-1 made it easier.
Mm-hmm. So if we can use a 1-to-1, should we be using a 1-to-1? Yes. I've had people that will subtract this over. They subtract this over. Yeah, I can do that. Yes. Then they had to do a division. Then they had to change forms. And then they had to multiply by the denominator, and they ended up with this when they could have just gone there. Okay?
Sometimes when you get going, you just don't think.
Yep, sometimes we do make it harder on ourselves. Okay, log base 6 of 3x plus 4. I'm going to check and see if it's our last one. No.
It's not.
Okay, log base 6 of 3x plus 4 minus log base 6 of 5 equals log base 6 of 2x.
And well,
Go ahead.
we compress it and to condense
It's
it
okay.
Okay.
We are, and you're correct. Why do we have to do that?
because it's a minus.
Right, and there's 2 things there, right? I can't just add it over. Well, I could add it over if I wanted
You
to.
could, and then you would just have to do
The same thing anyway.
yeah.
Okay, so I have log base 6 of what?
Log base 6 of 3x plus 4 over 5 equals log base 6 of 2x, and then it's a 1-to-1 property.
So then I have 3x plus 4
Over 5.
over 5 equals 2x.
And then you would multiply the 5 over. So it would just be 3x plus 4 equals 10x. So divide the 10. No. No. Yeah, that's 3x. Makes easy. Divide by 7. it would be 4/7.
Good job.
Why did you make those marks?
It when my hand rests on it.
Oh.
Good job, Isaiah. Okay, he could have added this over, and they would have had multiplication right away, right?
That's what I do.
But does it really make a difference? Nope. He combined them. He condensed them, so he could use the 1-to-1. He saw if I put these two together, I can use the 1-to-1. What if they didn't have the same base? Could I put them together?
No.
No. Okay. I have 2 times 3 to the t 2t minus 5 minus 4 equals 11.
You can add the 4 over.
Add the 4 over. You guys up with that for Ethan? So 2, 3, 2t minus 5 equals 15.
If you divide the 2.
I have to divide the 2 as well because I can't do anything until I can get to the exponent, right? So 3 to the 2t minus 5 equals 15 over
So 7.5.
2. Okay.
I'll go to computation.
Now what?
Rewrite it.
Rewrite it. The same thing when you say, now what? Rewrite it. So log base what?
3.
Log base
Log base 3
Log base 5.
of 15
Half.
halves equals
2t.
2D.
2t minus 5.
Okay, grow up.
And then
You're done.
no. It has to be t equals.
oh, you have to subtract. Well, you have to expand.
Oh, we could.
I'm so excited
We
about
could.
I'm gonna add the thought.
We could expand. We should probably expand. Is there a 3 in 15?
Yeah.
Yeah.
5.
There's
Well, that's unfortunate.
3 times 5, so that'd be. Yeah, but that's just going to make a mess. Let's worry about solving for t for right now.
Add the 5 over.
Add the 5.
No solution.
Yeah.
Go.
No solution.
Guys, this is really kind of easy, so I wouldn't be jumping to no
0.
solution. Equals.
2D.
2.
And then what?
Divide by 2.
And then divide by 2.
Got a whole thing by 2.
Now, if we want to. Oh, I'll just do this first. Log base 3. I don't know. Don't pay attention to that. Okay, so we're good. But this is 3 times 5, yes?
I got 6 plus the log base 3 of 5 minus log base 3 of 2 over 2 equals 2.
I'm gonna erase this last problem so I have room to go.
They're still going.
Well, we got that 3 in there.
Hey, is there still more to do?
So we have 5 plus log base 3 of 3 plus log base 3 of 5 minus log base 3 of 2.
Where'd the 15 go?
3 times 5.
Oh, okay.
Okay,
Wait, would you put brackets around the, instead of at the end of log base 3 of 2, would it be at the end of log base 3 of 5, so you know to...
well, I just did this so my brain knows that I'm talking about this whole thing.
Okay.
Okay?
So that
Because it's not multiplied, it's added. You see that? So I just did it so I know. What is log base 3 of 3?
1.
1. So it's 5 plus 1 is 6 plus log base 3 of 5 minus log base 3 of 2 all over.
2 equals 2.
That's a horrible division sign.
And then it would be 6.
No, we can't do anything else. Cannot reduce 6 and 2.
No, I was just gonna put 5 over.
Oh. Oh, okay.
Couldn't you do 6 plus log base 5? No, you can't, because you can't.
I I was gonna condense.
The only thing you can do is condense these two if you want.
That's what I was meaning.
Divide.
Oh,
the 6.
log base 3 of 5 halves.
Yeah.
And no, you cannot reduce to 6 and 2. Why not?
I don't know, that's why I asked.
Because it's
Because this whole thing is a quantity, and is there a 2 in front of everything?
No.
No. So, do they get a little bit complex?
Nope.
Yeah, you're doing my homework.
Okay,
You're good.
log base, log of 4x. I think this is the last slide. Yep. Okay, log of 4x minus log of 12 plus the square root of x equals 2.
I don't ate for a couple minutes.
Brian's hungry. Oh, the square.
I don't see what together.
Do you not see him taking notes?
No.
That's weird.
Take notes in my hand.
Compress.
No, you don't.
Condense. I mean, they sound they're the same word, pretty much.
So, do you drink compressed milk? Yeah.
I don't think you
I mean, they
use
both
drink
begin to
condensed
make
milk.
smaller. Well,
Okay,
you can-
so on this one on K, we are not going to add the log over because we have a 2. And that would make this problem more difficult to deal with, yes?
Yeah.
So we have log of 4x over 12 plus the square root of x equals 2.
Could you do take all that to the 1/2 power?
No.
You know. The only thing to the 1/2 would be the x, and we don't need to worry about it right now.
Okay.
So now we need to do what?
Change.
Change forms.
I was
So what's my base?
close,
10.
but-
10. So 10 squared is what?
100.
100. Would I expect you to write that?
No.
Yeah. Yes, you would.
Why did you do that? I dream that we thought.
Okay. So it is a fraction, yes?
Multiply.
Probably would have.
I multiply. Every time you have a fraction and you need to solve it, you have to multiply by the denominator, correct? So I have 100 times 12 plus the square root of x equals 4x. And you notice I did not distribute the 100 because I'm going to do what with it right away?
Divide it.
Divide it.
So that would be 25.
So that'd be 1/25 x.
Yes. Ms. Smith, I do have a question.
What?
Why did you put the 100 in front of the 12?
Because I multiplied it over.
Still not quite sure what multiplication is. You're gonna have to take it a little slower.
Okay. We've got a problem, right? We got a square root. And we've got an x. I'm going to
Leave it there.
subtract. I'm going to move all this over here. And I have 1/25 x minus x to the 1/2 minus 12. Yes?
Don't let your hand hit the.
Yes?
Yes.
Equals 0.
Yes.
Now I'm going to perform some acrobatics. You ready?
Yeah, you are.
Okay. I don't want 1/25. Anybody else agree with me?
Yeah.
Okay. So I'm going to multiply the whole thing by what?
25.
No, or 25. Okay.
27.
So 25 times 1/25 is 1. So I get x minus 25x to the 1/2
So that would just be 5x.
minus
Wait, next.
300
Wait.
Equal to 0.
equals 0.
I do one. Wait, what?
25 times 12 is 300.
Why'd you put 250 at the top?
Because 10 times 25 is what?
Yeah.
50.
And 2 times
Oh.
25 is?
Doesn't matter.
Okay, so now, ready for some even more magic?
No.
Oh.
Yes, Bishop, but I'm ready.
No, you guys need to listen because you're running out of time. I'm showing you what can be done. Did I just make that a quadratic equation?
Where did the other half come from?
Okay,
Exactly.
what is
That's equal to
1/2 times 2?
You just made it.
1? Yes?
Yeah.
Okay. So then can I factor it? Yes. I have factors of 300 that have a difference of 25. So I'm going to have x to the 1/2 and x to the 1/2. And what are the factors of,
So where'd your square?
what about, oh no. I need factors of 300 that have a difference of 25.
You got it.
I don't know. You
6 and 3.
give me a
Yeah,
couple seconds.
I'm still trying to figure out where you got the other 1/2 from.
What's 1/2 times 1/2?
1.
1.
4.
It says squared right there. That means I have 2 of them. What?
She meant 1/2 times 2.
And that's 1/4.
Oh, the
Get outta here.
exponents. Evan, I'm still recording. Shut the door, please. Shut the door, please. Okay, so I need factors of 300 that have a difference of 25.
Number.
10 and 30, no. 20 and 15, no. Anyway, those factors would go here, okay? So, will you have a lot of those? No. Do I expect you to ask me about those tomorrow?